Hi guys, Dr. Diaz again. Now we're going to discuss Riemann sums. It's part of what we're doing with summations and area under the curve. So here we have Riemann sums, and it says basically, look what it says here. We have seen the continuous. We have seen that for a continuous known negative function f, the area under the curve f of x is limited by the Riemann sum, which now we're going to do is add the whole thing, find the area under the curve by using the same expression we were using before. Now, here's a little bit down here is the definition of the Riemann sum, which says if f is integrable on a and b, then the integral, limiting integration from a to b of f of x, is equal to the summation, which is the Riemann sum, where delta x is that partition that I was talking about in the previous video, and xi is equal to a, or x naught, plus I delta x. Now what we're going to do, we're going to do an example. Look, we have an example here. And it says here, evaluate the sum for f of x is equal to x cubed minus 6x, and the interval from 0 to 3, which actually will be the integral 0 to 3 of x cubed minus 6x of delta x, which is equal to the summation. And here we have delta x, and we have the partition. So let's start. Let's find delta x first. Delta x for our case. Well, let me change this color. Delta x is equal to b minus a. B is 3, a is 0, divided by n. So we get here that delta x is 3 divided by n. Perfect. Now delta, let's find xi, because we found delta x. Xi is going to be a plus I delta x. A, according to our case, this is a is equal to 0, and here we have b is equal to 3. So this is going to be what, 0 plus I times delta x, which we already found is 3 divided by n, is going to be what? 3 divided by ni. So we got delta delta x as 3 divided by n times I. Okay, good. Now, the function, because if we're going to use this expression, this is f of x of I. How do we find x of I? Well, basically what we're going to do here is we're going to evaluate the function in f of 3n of I. And how it looks like. Okay, look at the function. The function is basically what? X cubed minus 6, right? Minus 6x. But this is not just x, it's actually xi cubed minus 6 times xi. Which if we evaluate then 3i, this is going to be equal to what? 3 divided by ni cubed, because this is the xi we're substituting here, right? Remember, we got 3x. We got xi, we put in here inside of this thing, right? Inside of here, and inside of this one, minus 6 times 3 divided by ni. So our function f of x, I'm going to write it here again. So I'm going this on a lot of details, so it will be easy next time you solve a problem knowing who is this. Okay, we got I. Perfect. Now, let's substitute this into the function here and see how it looks. Then, by definition, the limit of n going to infinity of the summation of f of xi delta x is equal, in our case, is equal to the summation of the x cubed, which now is 3i divided by n cubed, minus 6x, which now is going to be 3i divided by n. Now, here we have two different summations. We can separate this a little bit. So this is going to look like something like this. Do it in a second. Oh, I forget times delta x, which is 3 divided by n. Now we're going to do the other part here in a second. Now we see I separate this into two summations. I took here the 3n in front of the function because it doesn't have any I, so it can go off the summations. So we can put it here the 3n that it was here, the delta x, and then we have here the summation of 3i divided by n, which is this one alone, minus 6 times 3i divided by n, which is this one. Now we're going to take this one as a common factor outside, take the 18 as a common factor outside, and this is going to look, I'm going to write here in a second. So we start putting here, I took the 3n like we said a moment ago. We have the summation, but this in here, 3i cubed, well, 3i cubed is what? Is 27i cubed divided by n cubed minus. Then 6 times 3 is going to be 18, so we can put the summation here. Go from ni equal to 1 is going to be 18i divided by n. Close the bracket and the parenthesis here. Now, look at this thing. We're going to take as a common factor here the 27 and n cubed outside here the summatory, and the 18n here in this part of the summatory, like this. Now you can see I took the constant, the 27n cubed outside the summation, the 18n outside the summation, and the only thing we had to do is what is summation of I cubed and I. And you remember there's two formulas for those. And here, according to the formula of the summation of I cubed, this is from the textbook, m times n plus 1 divided by 2 square, which is going to be, well, n to the 4 plus 2n cubed plus n divided by 4, or if you want individual, it's going to be this one. If you do the summation, and everybody know this one, it's more simple, of 1 to n of I, this is just what? n plus 1 divided by 2. Or if you want it, it's going to be n squared plus n divided by 2, or n squared divided by 2 plus n divided by 2. Now, we're going to put these answer, this one and this one, into this one goes here and this one goes there, and see how this number looks like. So I'm going to do it here in a second. I'm going to put these equations, so save a little bit of. Now you can see that, well, we have, remember the 3n here? Here's the 3n. This 27n cubed is this 27n cubed, and the summation of I, which is this one, I put it here. Minus 18 divided by n, we have it here. The summation of I, which we did it here, is this fellow, and I put it here. What we have to do is, well, regroup, cancel whatever to cancel, and let's see. This one is going to be lim when n goes to infinite, and look, 27, I'm going to do this one in a second, so that we save more time. And look what we did. I multiplied 27 times 27 divided by n cubed times n to the 4th, and I get this one, 27 n divided by 4. You know, there's 3, there's 4 here, cancel at least 3 of this, you have what? 27 times 2 4th, which is 1/2, it's going to be 27 half, the n cubed cancel. 27 times 4 n squared divided by 4 is 27n, because this one has a cube. 18 times this divided by 2 is going to be 9n, and 18 times n times 9 n half is going to be 9. Now look, we can regroup this fellow with this fellow. This one has an n, and this one has an n, and then after that we're going to multiply them by 3n. So I'm going to do it here, and let me save more time here for the second one. Actually, what I did here is just simplify this. So 27 divided by 4 is 6.75, 27 divided by 2 is 13.5, 27 divided by 4 is what, 6.75, and then, okay, now we regroup n's with n's and numbers with numbers, and then we will get this. Second, I will show you, saving more. Now we're going to distribute, well, we get this times minus this is negative 2.25, then we have 13.5 minus 9, 4.5, and then we have 6.75 divided by 9. Now we multiply all of these by 3 divided by 9, and we will get something like this. Show you in a second. We save more. Then multiplying 3n times negative 2.25, n and n cancel, and you just get negative 6.75. 3n, 3 divided by n times 4.5, you get 13.5 divided by n, and 3 divided by n times 6.75 divided by n is going to be 20.25. And now we use summation. Look, I mean, the limit. When n goes to infinite, this number is 0. This number is 0, and the limit is just negative 6.75. Well, what it means negative is that the area under the curve, instead of being over, it's actually here below the x-axis. Probably the graph looks like, well, it's a x cube. It probably looks like this or something like that. Well, the thing is under in this area instead of being here in this area, which usually will give you a positive quantity. Okay, so the problem, the summation of this crazy stuff, if you go all the way up, summation of this one is equal to negative 6.75. That's it, guys. Okay, I hope this helped a little bit. See you next time.